Continuing our look at subroutines and MIPS, what we're going to do today is have a look at some basic methods from the Java String API and how to implement them as subroutines. So these are methods that you call on a string and it returns some information based on whether that string meets some criteria. So today we're going to have a look at isEmpty, which tells us if a string is empty and should return a Boolean value. We're going to have a look at length, which returns the length of a string. That's one that will be quite familiar to us all by now. And then finally we're going to have a look at equals, which takes two strings and compares them piece by piece to see if they are the same string. So we're to assume that the string these subroutines are being called on is stored in A0, and we'll get on to equals because that takes two strings later on. But let's start with isEmpty. This is a very simple method. So what we do, we load the byte unsigned from T0, and what we do is we take the value from A0 and we just set equal. So we want to say, let's use T0 is 0 equal to the value stored in A0. So this is saying is car equal to 0, 0, which is of course the null byte for strings. So then we just want to, actually no, we don't want to put this in T0, we want to put this in V0. Let's put that in V0 because then I don't have to move it. If I didn't put that in V0, I would have to move the result bit into V0 because that's part of the MIPS calling conventions where the return values are stored in V0 and V1. So I'm going to put that in V0 just there to make it a little bit easier for myself. And that's us done. All we need to do is get the byte, check that it's equal to 0, and if it's equal to 0, we return 1 to say true, it is empty. Otherwise we return a 0 to say false, is not empty. So then we just jump to the return address. And this is the same as in our calling conventions, hand back control to caller. And that's us done. isEmpty is a very simple method and it's very simple to implement as a subroutine. All we need to do, get the byte, check that it's equal to 0. If it is, return a 1. If it's not, return 0. So that's very straightforward. Let's have a look at length. So we've done this before, but let's do it again for the sake of setting up as a subroutine. So what I'm going to do is I'm going to move the value in V0. I'm going to set that equal to 0. Because I don't know, because this is a subroutine, so this could be called from anywhere. This could be called from another file, it could be called in this file, it could be called anywhere. But I don't know that V0 is going to be 0. So this makes sure V0 equals 0. And I want to do that just in case perhaps the person calling me has used V0 before. I'm going to use V0 to store a counter. There are other ways you could do this. You could set another value to be equal to 0 and then use that as a counter and move it into V0. It's up to yourself. But either way, you'll need to make sure that the register you have is set to 0. We can no longer just assume that the registers will be 0 because these could be called from anywhere and you don't know what the state of the registers are when it will be called. So you need to make sure that it's ready to implement itself in a way that makes sense without just adding values onto a value that's already stored there. So now that I have that, I can do length. Oh god, I cannot spell today. It's too far into the semester for me. So now I just want to loop through the list, incrementing every time I find a byte that is non-zero. So let's load byte unsigned, put that in T0, and it's going to be from A0. Now remember, I'm using the registers T0 because these are not saved, or these are not saved registers, so I can use these freely as a subroutine. As the person that's calling me needs to make sure these are saved if they need them to be saved. So we get the byte, or car, from the start of the address, and then all I need to do is branch if equal to 0. And I'm going to say if T0, then go to end, let's put that lowercase, end length. So if 0, go to end. And we'll put that in later. I'm just going to finish off this loop while we're here. And if it's not 0, then I want to add I to A0, value that's in A0, and 1. And this will increment the address so that I can get the next byte. So move address to next byte, or car, whatever you prefer. But I'm not done yet either because I need to add into V0 because that's where my counter is being stored. So I'll add to V0 the value of 1 and say found non-zero car, so increment. In this case we've already figured out that it's not 0, so I just need to increment my total. And then I'll jump back to length loop. Otherwise, I've finished because I've found the 0 byte, so otherwise I'll have jumped down to end length. And that means I can just jump register. So this returns me to the register stored, and return to program counter stored in array. I've also realized up here I just put jump array, not jump register. Now jump register is important here because that hands back control. Just using jump wouldn't take me to the register address. It would fail in that case because it's not given a label. So that was a silly mistake on my part. But that's just done two of the methods. So you can see this is actually fairly straightforward. At least these two are. These two are very easy to implement because they're very simple things. And we've also done a lot of things like length. So equals will be a bit trickier because we have to do a little bit more thinking and a little bit more work. But let's tackle that. So first things first. The way that I'm going to write this, I'm going to assume that the strings are equal until I've proved otherwise. So when I start off, I'm going to say make the return value 1 to be a boolean true for the two strings are equal. And then I'm going to loop through it and I'm going to say if you ever find two characters that are different, then set this to be 0 because it's not true. So what I'm going to do, add immediate into v0, the value of 0 and the value of 1. So assume true at start. Now this is just to put a value of 1 into v0. Again, I don't know what the value of v0 is at this point in time, so I can't just assume that it's going to be 0. So I need to make sure it is 0 before I add something in there. We're going to overwrite this value anyway, so even if you wanted to store a value of 1 in another register, and then you would then still have to move it across. So I'm just putting it into v0 because that's where the return values go. So let's think about how we want to do this. So let's call this equals loop. Now, what I want to do is, I'm assuming in this case, actually let's put that in. So we assume string 1, that's the one that we're working on, but I think the one we've called it on, like when you do dot equals, you're calling it on a string object. So we're going to assume that that's the one that's stored in a0. And we're going to assume that the string 2, the one that's passed as a parameters to the equal function, we're going to call our method, we're going to say that's in a1. So we assume we have the addresses of these two strings to work with. Now let's see what we should do. Well, what we want to do is loop through each of these strings going at the same time and comparing each byte. And if they are ever not equal, we want to set the value in v0 to be equal to 0 and then just exit. Doesn't matter if we don't want to check the rest of the list because there's no point if we've already found out that they're not equal. So we're just going to exit as soon as we find something that's not the same. So let's start off by saying load by entity not value in a0. And this is just saying get car from string 1. Simple. And the next bit is going to be fairly simple as well. So we're going to load byte from T1, sorry, and A1. And this is get car from string 2. Again, so this is a fairly simple start. Now, what we need to do is say if these are not equal, we want to go to the end. So branch if not equal. So this is actually fairly straightforward as well. And then we go to not equal. So if different jump to end. So again, the logic is not so bad here. Now we need to do something else. So we've said if these are not equal. So in this case, we are assuming that they're equal now. If we pass by that branch if not equal, they must be equal. The only way that they can branch there is to be not equal. So in this case, if we get to line 29 of the code here, down here, they must be equivalent. But that doesn't mean we're done checking them yet because we do need to check that they're not 0. So if one of them is 0, then we have ended the strings, we've gone to the end of both of them, so we should just finish and go to the end. So we should do a branch if equal to 0, where we just go to end, or we go to EQ, let's call it T1. Oh my god, I cannot type today. So we go to the case which is equal. So if 0, done. And that's just because we've gotten to the end of the string and we don't need to do any more work in that case. So far so good. Next, we'll need to increment our addresses. And let's do A0. So it's going to be A0 plus 1. So increment address. And then we do the same for A1. So far so good. And now if we've gone down to this case, we just want to go back up to the start of the equals loop, so we just jump to equals loop, and that'll take us back up to the start and we'll iterate through. But I'm not done yet, because now I need to define my labels not equal, and in this case what I want to do is make sure that v0 is 0. So what I'm going to do is move into v0 the value from the 0 register. There's other ways you could do this. I'm just doing it in a fairly straightforward way. Not equal 0. Actually, we should say return 0. Otherwise, and then in this case, we also want to jump register to RA to get back control, and then we want the EQ case where we also do jump register of RA. And that gives back control as well. Now you could do this in a way where you don't actually include this jump register here on line 35, because if you've done this move you'll just fall through into the EQ case. I'm just putting it here because I think it lays out the logic more clearly, showing you that you need to be careful of jumping back to the register when you've finished off whatever you're going to do. So you need to be careful in your branches that you jump back to the register whenever it's appropriate to do so. But that's just that's something that you could change and it wouldn't hurt you at all. So that's everything done. So let's assemble this and make sure it works. Yep, I've mistyped that, as I did every time I type 0. So there we go. So that's assembled. Now let's have a look at the string methods test. So I've got a couple of strings up here. I've got string 2, which is Miami connection. I've got string 3, which is face off, and string 1, which is an empty string. So what we have here is we're going to load into the address string 1 and check that it's empty. This should return 1 because it is in fact an empty string. Now string 2 in this case should not be empty, so we should get a 0 back. And in this case when we're doing load the address of string 2, which is Miami connection, and then we call jump and link length, we should get 16 because Miami connection has 16 characters in it. Same for here, this is when we have face off, that should be 8 characters. And here when we see a face off and Miami connection are equal, that should be 0. And here when we compare string 2 to itself with equal, that should return 1. Now you'll notice in here I have a little jump and loop print help. That's just going to move things from v0 into a0 and then print so that we can see the results clearly. So this is all that's doing. It's just a little test file, it's nothing too exciting. But let's assemble and run. So you can see we got 1016801, which is exactly what we would have expected. So these methods have worked correctly, they've worked as they should have. So that's everything for today. I hope you found this useful. This is just some basic subroutines, and I hope that linking it back to Java makes it a little bit clearer what subroutine is. If you have any questions about this, please do let me know. Thanks.